We will look at Java interfaces, what they are, how they are used and why, and how they differ from classes, especially abstract ones. I will give you an example from the real world. This is an object in my possession, and as with any other object, we can consider what's on the outside, in this case, people who want to switch it on and brighten the room, and what's on the inside, which in this case involves the inner workings of a light bulb, some physics, etc. The nice thing in an object-oriented design perspective is that this lamp, this object, encapsulates all the internal complications and hides them from outside users. Outside users only need to know the interface of the object, meaning the collection of its public-facing services. In this case, that is the little switch down here, which allows me to switch the lamp on or off. Turning to programming, consider this class lamp and some user code here on the left. Now imagine that these pieces of code are written by different people, perhaps even at the same time in different programming teams, say. Now ideally what you want to do is specify upfront, before either of those teams starts doing anything, what services this lamp class should offer. So you want to specify what should be the public methods and attributes and so on of any lamp object. And that is exactly what a Java interface allows you to do. In code, this looks as follows. An interface definition is very similar to a class definition that only contains method signatures, so none of the method bodies, and the syntax uses the keyword interface instead of class, and all of this would live in a .java file, just like a class source code does. Now, an interface in Java defines a type, and this means that the user code on the left could actually use a variable of type, in this case switchable, which is the name of the interface, and use it accordingly. On the implementation side, you would want to say that a class that you're currently writing actually implements a given interface. This will be done using the keyword implements like this. And now this class is connecting to the interface from the implementation side. In Java, an interface is really a specification which public methods and attributes should exist in any class that implements this interface. You should think of this as a formalization of a contract. Both sides, the application programmer as well as the implementation programmer, have to adhere to that contract for the code to compile on both sides. An interface defines a type, and it typically only contains constant declarations as well as method signatures, not the method bodies. An interface cannot be instantiated, so you cannot do new switchable, for example. That isn't possible for an interface called switchable. An interface can instead be implemented by a class, which then has to provide method bodies for all the methods which are declared in the interface itself. And interfaces can extend other interfaces. Finally, a class can implement one or more interfaces. And I will give you an example for each of the two bottom points here just now. A class can implement several interfaces, and that pretty much just means that it would have to provide implementations, method bodies, for all the abstract methods declared in all the interfaces it wishes to implement. The syntax here looks like this. Whenever you're using the class definition, you use the keyword implements followed by a comma-separated list of interfaces that you propose to implement. An interface in itself can extend other interfaces, and again here you can extend one or more other interfaces. So the following is a valid first line of an interface definition. Public interface dimmable extends switchable and pluggable. And what this simply means is whenever you want to implement dimmable, you really have to provide implementations for all the methods in switchable as well as pluggable. An interface cannot implement other interfaces. So this line of code, public interface dimmable implements something else, is just syntactic garbage that doesn't work. And that makes sense because in order to implement an interface, you would have to actually provide implementations for all the methods, which simply isn't allowed syntactically in an interface declaration. Let me mention here also that a class can easily extend or inherit from other classes as well as implement several interfaces. So you can use both the implements as well as the extends keyword whenever you're defining a class. A word on conventions. As you have seen from the examples just now, the interface identifiers in Java typically end in able. So examples would be comparable, serializable, and others. These actually appear in the Java standard library. Also, all interface methods are public and abstract by default, so you don't have to add those modifiers. You can omit them if you want to. And similarly, all attributes in interfaces are public, static, and final. So they are really constants, and you can drop any of these modifiers if you like. So now you might think, well, all of this can be done using abstract classes. I can just define an abstract class and add all abstract methods that I want classes to override. And that is true, but there are subtle differences, technical differences, as well as differences in what abstract classes and interfaces are originally designed for. So technically, in abstract classes, you can only extend one superclass. So there's a single inheritance in abstract classes as in for any other class. Whereas, as demonstrated just now, interfaces can have multiple inheritance, so they can inherit from multiple other interfaces. An abstract class can extend any class, whereas an interface can, of course, only extend other interfaces. An abstract class can have abstract as well as concrete methods. So you can provide some methods with an implementation in an abstract class, but in interfaces, you can only have abstract methods. In abstract classes, you can also have protected methods. And these make no sense in interfaces because interfaces are there to declare what's public. So in interfaces, you only have public abstract methods. Finally, in abstract classes, you have no restriction on the attribute modifiers, whereas in interfaces, you only have public, static, final variables or attributes. The crucial difference really is that the purpose of abstract classes is to provide some kind of abstraction when you're designing a type hierarchy or class hierarchies, whereas interfaces are intended to formalize, to specify the public-facing services in order to coordinate several groups of programmers or different parts of software.